Today we're going to be looking at special cases inequalities, namely identities and no solutions, and how it looks like in simple inequalities and in compound inequalities. Sometimes when we just look at the graph, we'll rapidly see what the answer would be, whether it's a no solution or an identity. So let's look at the first one. So here we have a compound inequality with the word and. So this is really going to be a conjunction. So they're conjoined. We're going to look and see where they intersect, and that will be the answer. So if we solve first inequality, r is greater than or equal to 3, and r is less than or equal to 0. Okay, so we have two things, and we're looking at and. So we have to look again at the conjunction where they intersect. So let's go ahead and graph this. So the first one, r is greater than or equal to 3. So we'll go to 3, and it will be shaded in, and greater will be to the right. The next one, r is less than or equal to 0. We go to 0, shaded in. Now we go left. Now if this had said or, then we would have a solution. But because the graphs do not intersect, then this would be a no solution. So they do not intersect. So we would have to say, because it says and, it would be a no solution. Let's look at the next one. So again, the graph here, at first it looked like we had a solution, but when we graphed it, it was clear that they do not intersect, so it is a no solution. Again, we have here two very simple inequalities. So we just have x is greater than 3 or x is less than or equal to 3. Again, just graphing it on the number line. All right, so here's the first one. X is greater than 3. Open at 3. And then greater than would be to the right. The next, less than or equal to 3. So we are shaded in at 3. And then graphing to the right, because it is less than. Because it is or, we are really looking at one or the other. If we notice here, if we look at this, we see that everything is shaded in because it is less than 3 or greater than or equal, or greater than 3 or less than or equal to 3. So this would be all real numbers because we really have the whole number line. So when we see the whole number line shaded in, it would be an identity. So the whole number line is shaded in. I mean, we wouldn't necessarily have to graph it if we wanted to. We can see greater than 3 or less than or equal to 3. That would make sense that it would be all real numbers. Now sometimes we don't even need to graph it because the equation shows the answer as the variables disappear. So how would we know if it was an identity versus a no solution? So let's just think about that. So identity or a no solution. So identity, you would end up with a true statement. And a no solution, you would end up with a false statement. So you're just looking at, is it going to be something that's always true or always false? So let's look at the first one. All right, so the left-hand side, 2r plus 5 greater than 2r plus 8. We subtract the 2r's, and we have 5 is greater than 8, which is totally false. So our answer is a no solution. The next example, simplifying the left-hand side, we have 4x minus 2 less than 4x plus 5. Subtract 4x from both sides. We have negative 2 less than 5, which is always true. So our answer would be true for all real numbers. And that's it for today.